right, looks like we are good. And welcome everybody to another episode of our Labs Open Office Hour. This week we're joined by Mr. William George. He's our resident photogrammetry engineering and CAD. I think those kind of all lumped together, right? Expert. Is that about right, William? You there? Am I good? Oh, okay. No, it's all right. Yeah. So I'm kind of this is you are also going to be our first one we're talking to from Labs after the AMD thing. So this will probably be a pretty interesting stream for us today. And obviously, on the heels of these sorts of announcements, there's always a bit of a kind of that gray area of what we know versus what we can talk about, and so a lot of this will probably be speculation and just reiterating marketing stuff. Yeah. So, but I know one thing we can talk about that I don't think you've really gotten a chance to kind of really drill down deep into is the new graphics cards from Nvidia and how those have affected your kind of piece of the pie that you focus on. So, yeah, let's kind of start there. What do you think? Oh, one moment. I don't think your audio is going out at the moment. Hang on. Something funny is going on here. And let's try this again. So let's see. William, give us a little test. Introduce yourself. Tell us what you're all about.
My name is William George, and I'm one of the guys in our labs department. I'm getting the thumbs up now, so I'm assuming the audio is working.
Yeah, we're good.
Okay.
Sorry about that.
Always fun with live streams.
Mm-hmm. Yeah.
That's actually one thing. I do live streaming stuff at my church, and it's always something always seems to go sideways somewhere along the line. So we try to test early. We use a thing called Restream, so I can actually go into that and toggle off the live streams that are going out from there and test just and make sure we're getting the reception right in Restream, and then toggle them back on. So we do that every week, I think. So
that's good to know.
Helps catch things. Yeah. And still stuff goes sideways sometimes.
Yeah, you deal with technology, you get technical issues, so
yeah,
it's all right.
Yeah. So I work with mostly photogrammetry and engineering programs, but I do actually also oversee our live stream configurations and VR configurations and basically a whole mix of things. If it's not photo editing or video editing that Matt handles, if it's not scientific that Don handles, and if it's not 3D modeling and like game dev stuff that Kelly's doing now, everything else is me.
Oh, that's cool. Nice, interesting mix. Kind of keep you on your toes.
It does.
Yeah. So before we had the audio fixed, we were just about to get into talking about the new Nvidia graphics cards and how they've affected your bit of a slice of the pie.
Yeah. So the biggest thing is probably the rendering stuff that I do. So Kelly at some point might take this over because it's really closely related to what he's doing in like 3ds Max and Maya. But the actual CPU and GPU based rendering engines, currently I'm the one that runs the testing on. And on the GPU rendering side, these are fantastic cards if you look at them as individual cards, the 3080 and 3090. They are tremendously fast, depending on exactly which rendering engine you're looking at. They can be up to twice the speed of like the 2080 Ti and Titan RTX. Some engines don't see quite that much benefit, but they're fast. The trade-off and sort of disadvantage, of course, is with those cards, well, the Titan RTX was always a situation where we couldn't really stack more than one of them. I could see someone maybe sneaking two in there, but they only came in a dual fan cooler design. They weren't available from any other manufacturers of cards besides Nvidia directly, so we could never really stack those. But with like the 2080 Ti, it was extremely popular to have four of those blower versions stacked in a single system. Sometimes even more than that in a rack mount. And you can't really do that with the currently released 3080s and 3090s. The Founders Edition design that blows through, we're looking at maybe being able to offer two of those in a system. Which means you might have the same horsepower as four 2080 Ti's, for a lot less money and less
Sure.
complexity and less power usage, but
Hmm.
you're not actually going to get more performance. You're just going to get the same level of performance with a bunch of savings,
Sure.
which is great, but not an improvement in raw horsepower.
Yeah.
So we're hoping that blower style cards end up coming out. The only manufacturer I've seen that's announced one yet is Gigabyte with a 3090 blower, not a
Oh,
3080, but
interesting.
a 3090.
That's definitely
So
interesting for the 3090 because you'd think they would have started smaller to kind of get a handle on because there's
yeah,
just less thermals to have to deal with. So man, they're jumping in with both feet. That's pretty cool.
yeah. So that's, I mean, I assume if they can do it with a 3090, they could do it with a 3080. Maybe they don't see as much market for it because the 3090 is faster and has more VRAM, which is a big thing for rendering
Sure.
folks. So maybe that's kind of what their thought is, but we're hoping to get some of those in as soon as they can get us samples. We've already got some NVLink bridges. So
Ooh.
that'll be a thing to test out too, is a pair of them in NVLink for those that need access to potentially even more VRAM. Um, but yeah, so I'm excited to see where things go with that. But that's kind of the effect it's had on the rendering side. Um, it, in terms of engineering software, no real effect. Most of those we recommend Quadro and professional grade video cards for anyway. There is the newly announced RTX A6000 from
Oh,
Nvidia
sure.
that
Yeah.
should, on paper
Ooh.
anyway, looks like basically a 3090, but in their professional series, they've dropped the Quadro naming as far as I can tell, but
Yeah.
it's supposed to be aimed at that market. So that'll be interesting whenever it ends up reaching us. No
And
idea on that.
and before I say this statement, we're allowed to talk about the pictures, right? Like that's a public thing. They've actually shown pictures of it.
I think so. I know at least the cooler. In fact, actually, I think that was the weird thing
Because
that I saw was the
that was what I was
pictures that
going to
NVIDIA put
mention.
out looked like they were just the heatsink. Didn't look like there was
Okay.
actually a card there, but it was hard to tell
Because
too, like from the angle it was taken at. It may
okay,
just be
because I
that the
know
PCB is entirely hidden.
traditionally, I want to say PNY has been their third party manufacturer for the Quadro series, and those
Yeah.
tended to be blower style cards with the Quadros.
Yes, yeah. The picture that Nvidia has, like if you just go to their website and search up RTX A6000, it's a blower, which is good,
Okay,
but it's kind of a weird
so
looking blower. It's a very square, and again, you can't actually see any part of the card. It's the heat sink and
it's
the
just
bracket
the
is all that's
right.
visible.
Okay,
But
well, I
yeah,
suppose if they could do it with a Quadro, that at least gives the hope and opportunity that they could do it with any of the cards.
in theory, yeah, in terms of cooling, I certainly expect that to be the case. With blowers, really, I mean, I don't see how like it would just be a matter of ramping up the heat sink bulk and design and then just fast fans
Sure.
or fan singular, I suppose. Um, you just have to push a lot of air through, and those blower systems usually noise was much less of a concern. I mean, if you're putting
Right.
four video cards in a system, it's not going to be quiet. So
Yeah.
um,
You kind of just accept that part as, you know,
it kind of comes with the territory. Yeah. Actually,
yeah.
the more interesting thing I think when it comes to the RTX 6000, I don't see any reason. I mean, they haven't put out in-depth specs as far as I know, but I bet four of those could fit in a system and just be very,
Ooh.
very expensive.
Yeah.
The problem with the 3080s and 3090s might actually end up being power consumption
Oh,
because
sure.
they are over 300 watts per card. And it sounds like they go even higher when they're turbo boosting or
Oh,
whatever term
wow.
NVIDIA uses for that.
Sure.
So let's say 350, maybe 400 watts
Hmm.
plus a CPU. I don't think you can do four of those on the biggest power supplies that are available, at least here in the US. 1600 watts is pretty much the largest power supply
Yeah.
you can get. And
Yeah. Because
if
you're
you
looking
had
at
if you had
over
four cards at
1200 watts
350
for the.
watts, that's 1400 watts just from the video cards without anything else in the system. And any of the CPUs that are going to fit four of these in a motherboard are going to be 100 to over 200 watts for the CPU, and then the RAM and drives. Like I think it may be that we can physically fit if they come out with blowers for 3090s, but we might actually practically be limited to three based on just
Wow.
power. We'll see.
Yeah. So actually, our coworker Kelly mentions that he was curious why the Quadro just has the single 8-pin cable while the 3080 has the new 12-pin, and that is pretty
Presumably using
curious.
less power. I mean that an 8-pin does 150 watts and the
Okay.
PCI Express slot does 75, so that's 225 watts, which is
Hmm.
substantially less than
Hmm.
what those other cards are pulling. But actually, if you look back at Quadros, it's kind of always been that way. If you look at the current, what is it, the RTX 6000 No A,
Yeah.
right now, I think only has one 8-pin as well, even though the 2080 Ti equivalents and Titan X have two. I'm pretty sure
Hmm.
that I'm double checking now, but
Sure.
because I could
I
be I
wonder. I
could be off.
wonder then. Would that then suggest a lower clock speed?
I don't know. It probably less aggressive turbo stuff. I think
Okay.
Quadros have
That would make sense.
tended in that direction. Man, I'm in trouble actually finding a picture. Oh no. Okay, it has an 8 and a 6 pin on the RTX 6000
Hmm.
now. So I don't know. It's interesting.
Yeah.
It is always possible as well that those renders that they've shown, again, at least the picture that's on Nvidia's website looks like it's just a render, not an actual physical product photography.
Okay.
It's possible that's supposed to be the new power connector, and somebody just didn't have that in their model or something. So that would explain it too. But I don't know entirely. It is kind of funny
Sure.
though. I noticed that as well, and I figured just chalk it up to lower power consumption on a Quadro variant, or well, Quadro equivalent variant.
Yeah.
They're not using that name anymore. It seems like, but yeah, I don't know. We'll have to see. I don't know when we're going to end up getting samples of those, but
Right.
that'll be interesting, and that will be more for the engineering side. Possibly rendering too. It just is going to be stupidly expensive to have multiple
Yeah.
of those in a system. If there's any chance of a 3090 blower or 3080 blowers, it's going to be a way better deal for most folks.
Yeah.
Um, so yeah, we'll have to see.
With
Um,
the with the robust performance of these newer the 3090 and 3080 cards, um, are you looking at adding bigger renders, like something more outrageous to test with, or like is it too easy now?
Maybe the thing is, like, one of the reasons that I'm the one doing the rendering stuff right now is all of those, at least all the rendering engines that we test make their own benchmark, which is really convenient. We don't have to go out and
Correct.
build our own thing, make our own scene, that sort of stuff. It's very simple to do. We just have some real basic scripts set up to automate them and pull the results and stuff.
Mhm.
Um, and it's true that as far as I have been able to tell, none of those scenes demand high amounts of VRAM or anything like that, which makes sense. You want them to be able to compare performance of lower end cards to higher end ones.
Sure.
I could see the main thing that would be interesting would be to have a test that was demanding enough that on NVLink connected cards, it actually could use, again, in supported rendering engines anyway, could use the sort of VRAM sharing that some of those can do. It's very
Okay.
dependent on the engine has to be written for it, but that would be kind of interesting.
Mhm.
And that's something that maybe, again, it wouldn't surprise me at some point when Kelly kind of gets his current testing ironed out. He's doing a great job with the game dev and 3D modeling stuff. Maybe we end up rolling this in, because really you could do the rendering tests inside of 3ds Max and Maya just with the rendering engine plugins, and
Mhm.
then he could use more complex scenes. That might be something we look into down the road. I think it could be really cool to do, but at the moment anyway, that's not something we're pursuing. We're just using the industry standard tests, and that way people can compare more easily anyway.
That's good. That's good. I'm curious too. So as you've had a bit of experience with these various softwares and stuff, what do you find to be the most common, um, I guess, ask? Like, what is it most people are doing with these software?
Well, rendering I think is pretty straightforward. People are just rendering, usually in the, at least in my experience, in the like architecture side, it tends to often be just like single images, whereas in like animation or other fields, it's usually a sequence of images for a clip of something in a movie or YouTube video or whatnot. Um, on the photogrammetry side, most of the people that end up at least talking to us and having like special requests and questions tends to be folks doing big drone photography of
Oh,
large
sure.
areas for mapping.
Okay.
Um, and then engineering, of course, is all over the place. People are, building prototypes of stuff, or all the way up to, big giant architecture projects. So that's kind of all over the place. Yeah, it's a big enough mix of stuff. It's hard to narrow down to just one sort of thing that people are doing.
Right on. And what sort of issues do people like kind of encounter when with this sort of things that our testing like helps to resolve?
The biggest thing, at least, that ends up coming to my attention is usually project sizes that are sometimes bigger than like what we are testing on a regular basis, because we have to balance. We want to make our testing real world and applicable, but we also want it to be able to actually get done in a reasonable amount of time. So we can't have tests that take days, for example, to
Okay.
execute on a regular basis.
What
So we've
what kind of
definitely
thing?
had
What kind
hmm,
of thing would take days?
large enough photogrammetry projects and long enough
Okay.
rendering. Like individual frames in a render, might
Hmm.
take maybe in some extreme cases a few hours, like for
Hmm.
something really complex. But now if you've got 10 minutes of that at 60 frames a second, suddenly you're talking days. Um,
Okay.
and then yeah, photogrammetry stuff just gets longer and longer the more images you have. And so if you're taking a map of a larger area, you're going to have more images. Or if you're trying to take something more detailed, even if it's a smaller area, just choosing to take more images. So we've
Okay.
we've definitely had some custom stuff where people have come to us and said, "Hey, I'm trying to do X number of images, and it's multiple times larger than what we normally test." And we've done a few custom things like that. We can also just use the test sizes that we have and sort of project out. Okay, well, if they're using this much memory and taking this long at different image size or image project sizes, then we can estimate and get you a good idea where it's going to be at your project size. So we do stuff like that when people want to come to us and make sure they're getting the right system for what they're doing. A lot of times the sales consultants will bring those questions over to us in labs.
Yeah.
We've also got a thing now where we're doing labs consultation stuff specifically. So if someone's maybe not necessarily even going to buy a system from us, maybe they can't because they're at a company that contracts with Dell or HP, but they
Hmm.
need to know what to get, and it's beyond the capabilities of Dell and HP to answer them, or they just monolithic companies like that. It's probably kind of hard to get them to do any sort of special project stuff.
Sure.
They can come to us and just pay us directly to do testing, and then they're free to use those results however they want.
Oh, okay. Okay. That's
Yeah.
pretty cool. Huh. I wonder how I'm curious how those conversations go after the fact. Like, hey, I talked with Puget and they say this, and then like how I wonder how I guess maybe easy, or I'm just curious how that experience goes for those sort of for those that kind of angle of customer that we have.
Yeah, I don't know.
Yeah, because it'd be interesting too to see. Um, I haven't noticed from hang on let me kind of restructure that sentence a little bit. When I was a builder, I didn't often get to see much of the use case in
Hmm.
engineering, and also like or in the rendering and that sort of a thing. The end product, like you see the label, you say, oh, engineering, but like that could mean so many things. You could be building bridges, or like I don't know, a supercharger, or that
Yeah.
kind of a thing. And I'm always interested in the use case things. Have you found anything? Have you encountered anything like super interesting?
Um, well, I know there's a company that's bought systems from us that was using them to do the CAD designing of like holsters for firearms. That was kind of
Oh,
a cool one. It was a company I'd heard of. I don't know if we're allowed to mention or anything, but I had
we have a
heard of
case
them.
study with them.
We have a case study. Okay, so
Yeah.
Safari Land. Yeah,
Hmm.
they're a great holster manufacturer. Um, it's we've got some automotive manufacturers that buy stuff from us too. There's all sorts of really cool stuff. nothing else specific is jumping out at my mind at the moment, but yeah.
Actually, I think I jumped in front of a question from Twitch. Random Slurpiness asked
Oh,
a similar question. Are there any cool testing workloads you can talk about that the labs team has tested recently? So I feel like that's a similar sort of question.
um, well, I don't know about testing workloads. I actually just did some testing on RAM speed uh,
Mhm.
on different CPUs, um, which will factor into an upcoming article probably later this month or early next. So that's been kind of interesting.
Mhm.
And one CPU in particular, and we're not overclocking experts. I'm sure overclocking people out there get stuff running at much higher memory frequencies, but just using the base settings that a specific memory module was designed for, one
Mhm.
of the platforms just didn't seem to like running at 3200 megahertz memory.
Oh, weird.
It was X299, a Core i9 10980XE,
Mhm.
and I mean it's not supposed to. It's officially rated by Intel for 2933, I believe,
Yep. Yep.
megahertz. But we were trying it at 3200, and some stuff was fine. Actually, the rendering tests like V-Ray and Cinebench completed okay. Uh, Premiere Pro and Resolve, I was just running some of the other guys' benchmarks to get some results. Those, I think it was Resolve. One of them crashed at a couple points, and I just had to
Mhm.
retry it a few times and eventually got a result. But Pix4D, one of the photogrammetry programs, just every single time I tried to run our extended benchmark, it would crash. No
Wow.
error, nothing like it was a weird, just the program would just stop. So I
Huh.
eventually gave up on that, and we'll put a note in there that at least with any, who knows, I could have maybe gone in and tweaked loosened the timings a bit, increased the voltage further, but we were trying to stick with just the timings and the voltage the memory was supposed to run at that
Right.
speed, and that CPU platform did not like it
Hmm.
in some stuff. And again, some things ran fine. That's one of the reasons we have to be a little bit more careful with things like memory speed for our workstations is, it's not just people playing games where, okay, their game crashed, they can go in and tweak stuff and run again,
Right.
that'll be fine. But like we have people depending on our systems for work that could be loss of hours or days of work if something crashes. So we have to
Right.
be as careful as possible about making sure that things like memory are as reliable as they can be.
So we actually have a really good question from Tim Schumann on YouTube. He asks, he just got his first 3D printer. Is there any program, app, process for 3D scanning that you recommend for the hobbyist home user? And I remember when we first
Scanning.
started dabbling into photogrammetry, you guys had me stand in the warehouse and you guys took a bunch of pictures of me. And I have, it's actually at my workbench back in the office. I still have the 3D
A
print
little
of
tiny
me.
Houston.
It was super cool. And
Yeah.
so I'm sure the process has improved since then. That was 3 or 4 years ago now. So I'm curious myself.
Yeah.
Can we make a better
I'm
Houston?
probably I'm not entirely sure what, because I haven't gotten into 3D printing personally.
Mm-hmm.
I kind of would like to at some point, maybe. I've got some ideas for projects, but so I don't know exactly, what's going to be the best in terms of providing the right file format or anything. But if you're just looking to do some real simple, taking some photos of something at home and trying to build a 3D model out of it using photogrammetry, I would probably give a shot. I mean, well, any of the three programs we use actually would be viable. The three that we test with are Pix4D, and
Mm-hmm.
I believe there is a free or very cheap version of it. We use the professional version that supports mapping and everything, but if you don't need the mapping, if you're just doing the model part, I believe there's a fairly affordable, if not free version um, that you could use for that. Then Metashape, Agisoft Metashape. Again, we test with the Pro version, but if you don't
Mm-hmm.
need the Pro version, there's a much more affordable standard version. And then Reality Capture is the other one we do. And it's kind of interesting in that they've got a new pricing structure, I guess you might say,
Oh,
where
okay.
you pay for stuff when you're done. So like we can actually do all of our testing without paying because we're never like exporting a finished product. We're just doing the
Oh,
processing, which is really
yeah.
handy. But if you want, you could, that way you can play around, you can, work with it until you get the 3D model the way you want it to be to export out of there. And it probably will still need some cleanup afterward, but you can get it to that point before even paying anything. And then you just pay based on like how complex the thing is one time to export it out. So that's pretty cool. And they're all fairly simple to use, especially if you're just doing modeling. You're not trying to do like crazy mapping stuff and whatnot. They're all fairly intuitive programs to use, I think. So I'd give a look to those, see which one matches what you're looking to do in terms of price and functionality. One thing I will say, if you're doing it at home, I'm assuming you don't have like a multi-camera setup where you can do it all at once or something.
Right.
Some stuff that I've learned over the years is you want to try and keep the background as blank as possible, and keep like lighting as even as possible. Like if there's shadows in one area and then you like, well, it's okay, step back. A lot of people will do it on like a turntable so that you can really easily like have the camera in a fixed position and just turn the object slowly.
Right.
And that's great until you have like shadows in a certain part that are then, the shadows basically moving relative to the object as the object is turned. So you want to have very even lighting, very even background, and then like a turntable or something so you can just rotate it easily. You can physically move the camera too. It just ends up being a lot more complex to do that. So there's some good video tutorials out there on YouTube you can look up as well about that. That'll kind of help guide you through some of that.
I remember it was a lot of fun. I think we did it at PDX Land shortly after the test that I was a part of, and we take a few pictures of stuffed animals or somebody's like mug or something, and we were actually 3D printing them on the spot. That was really fun. Yeah, that was really neat.
And beware of clear things and reflective things. Those don't do great with.
Which actually, it's funny you mentioned that, because we did do. We were requested to print someone's car. It was a Mini Cooper, and the point cloud couldn't determine where the windshield was, and we didn't really notice until we had sliced it and printed it, and it actually tried to print the seats because through the windshield.
Yep.
So yeah, clear objects are super
and there's
touchy.
There's tricks like people will use like almost like a spray paint sort of thing, but where you can clean it off afterward to just put like a flat opaque coating over stuff that's reflective or clear, so that you can get the shot of it and then clean your object off afterward. And then, you can manually go in and like change whatever texture or color that needs to be after the model's done.
That's cool.
So there's tricks.
Yeah. So rewinding back to the memory talking, Don actually, and Dr. Don, he was wondering, did Neatbench show a speed up? Because
that is he thinks it's actually not one I included in our testing for that specific stuff. I'm trying to think. Neatbench, my impression anyway, is a lot of people use it GPU. I could be wrong. Neatbench is not one of my programs. That's one of the things that I think Matt put together. It's one where there's an existing benchmark. I think Matt did the like scripting and setup of that, and I believe, it can use CPU and GPU, but because of the GPU emphasis, I wasn't really thinking about it. I was trying to look for programs that had heavy CPU components to them. Maybe it would have been a good one to include. Oops.
So I know that there are different ways to go about rendering. I know, having dug through basically all of our articles, you specifically will test CPU rendering versus GPU rendering, and why is there a difference? And what sort of reasons, I guess, would one over the other?
Sure. Well, traditionally, rendering's been around for a long time, and anything that's had computer graphics basically in it. So going back decades at this point now, and traditionally it was, everything used to be CPU, right? Nothing was GPU accelerated until they started doing that with games in the 90s, and then kind of went from there. But so up until, I don't know exactly when, sometime in the early 2000s, I think, is when GPU rendering stuff started to get dabbled with. But prior to that, everything was CPU. There wasn't even a need to say CPU based rendering. It was just
Oh, okay.
rendering.
Sure.
And so that's what like all the old traditional rendering engines use. The ones that have been around for a long time were all using that. And then when GPUs started to get more powerful, and especially when GPUs started to be used for other things, when Nvidia came out with CUDA and sort of the general purpose GPU computing, GPU stuff started to happen, is when people went, well, hey, video cards are good at doing lots of small things at the same time, small, simple tasks,
Right.
and in parallel. And that's exactly what rendering does, which rendering's ray or path tracing, usually, tracking the path that an individual photon of light takes, where it bounces off things, how the color and brightness and things change over the course of all that. And so you need to do that ideally millions of times to make a single scene. So it's lots of these little tiny calculations, and they don't interact. So it's not something that has to be in series. It can be parallel. And that's a fantastic thing for GPUs to do. So rendering engines like, I think one of the first was Octane Bench, as far as I know. And I'm not super great at the history side of this, but companies like that started to investigate into that and look into it. And now you can pack in a tower workstation. We could do 4 2080 Ti's. We're hoping to do maybe 3 3090s. We'll see. So that's a lot of horsepower compared to even say like a dual CPU setup. 4 2080 Ti's in a similar rendering engine anyway, where you similar features and stuff, outperforms two high-end Xeons. So why not go that way?
Sure.
And there's also some engines. What was that?
Is there an instance where a CPU rendering would be preferable?
Not specifically, not just from the nature of it being CPU or GPU. There are differences between rendering engines in terms of how they handle textures, materials, things like that. So some will work better with certain workflows or just individual preferences.
Okay.
And there are also some differences between rendering engines in terms of, I'm going to forget the terminology, but there are some that specifically try to make things as absolutely real world as possible. And again, I'm going to forget the names here, but so there are differences between engines, but in theory, either type or either sort of focus of rendering could be done on CPU or GPU. That's just a matter of back-end coding. The one advantage CPU stuff has is that you can have more system memory than you can have video card memory right now.
Oh, sure.
So for ridiculously large scenes, there is an edge there in that you can just have, 256 gig, 512 gig, 1 terabyte of system memory in some systems, whereas the biggest video cards are right now 48 gigabytes of memory per card. And if you have an engine that supports it and you put a pair of them in NVLink, that would be in theory as much as 96 shared between them, but that's still not 1 terabyte. So there's trade-offs. There are also, though, now GPU engines that can put some of the stuff in system memory. They call that out of core memory. It's not in the GPU's core memory. It's out of that. So it's slower, but it lets you work with bigger scenes than you could otherwise. And so then there start to be trade-offs. Well, are you gaining enough from the GPU speed that the slowness of accessing some of the stuff in system memory is still faster than CPU would be? There's lots of things.
Wow.
You kind of, if you're doing something cutting edge like that, where you are pushing the limits of hardware, in the end, sometimes you just kind of have to do some testing of your own stuff to see what way is going to be best. But we do our best to provide that information.
Yeah. That's pretty cool. Man, it seems like it's almost getting to the point where like your graphics card is practically a whole nother system, like a whole nother PC plugged into your PC.
Basically is, yeah. It's got its own memory, it's got its own control, GPU, its own processor, like the CPU. Yeah, that's kind of what it is.
Yeah, that's pretty cool. Oh yeah, there's comments about the future of rendering in GPUs easier to upgrade than having to buy a whole new workstation and whatnot.
Yeah.
Um, um, there was I had wanted to ask about the new PCIe generation, PCIe 4 coming
Yeah.
soon. Well, it's already a thing in AMD boards,
Yeah.
coming soon from Intel. Um, and it had popped into my head when we were talking about power draw. Is there, and I should probably know this, but is there going to be an increase in the power availability
Oh,
on PCIe 4?
I don't think I've actually looked into that specifically. That's interesting. Normally, the PCI Express generations have just been roughly a doubling of bandwidth each time. So version 1 to 2, 2 to
Okay.
3, now 3 to 4. And sometimes it's a little bit more, nuanced than that, but roughly a
Hmm.
doubling of bandwidth each time. Um,
And and also, I'm curious if there's been a little bit of trickle for the new what is it, 12-volt motherboard power. I wonder if that's going to have any effect on these higher wattage device. Well, it's GPUs right now, but I imagine going forward, just the entire system is going to be taking up more power. We
um,
have higher TDP CPUs, things like that. Unless something dramatic happens with ARM processors, I feel like power draw has just been increasing over time.
it has, well, yeah. I mean, on CPUs and video cards, I'd say it's been slowly creeping up over time, pretty much. Um, Something to remember with that 12-volt stuff on motherboards, at least my understanding of it, is a lot of it stems out of some California legislation that
Oh,
required some of that stuff for efficiency.
okay.
But it also, that legislation, at least if I understood it right when I was looking into it, is really tailored at small, compact computer stuff.
Oh, okay.
There's exceptions at the moment you start to get into things with like dedicated video cards and stuff.
I see.
Because if you think about it, if you are trying to like supply all the power through the motherboard or something, that's going to be a lot of wattage getting pushed through the board if you were trying to power video cards and stuff directly off of that. I think
Hmm.
it'll be interesting to see kind of how things go. If that is the direction things trend, I suspect there'll still be separate power connections from the power supply to video cards and other high power devices. I think it's just low power stuff like drives might get powered
Sure.
through the motherboard.
Okay.
I doubt whole video cards would. And in theory, that's supposed to be more power efficient. The idea is to have all the voltage change stuff happening in the power supply one time and then feed it all out. I think to things rather than having them all have their own voltage regulation stuff all over the place is my understanding of the idea. But also having like legislators be the ones trying to enforce PC standards, maybe not the smartest idea in the long run. So anyhow, my impression is that stuff probably won't have a whole lot of impact on our higher end workstations at least.
Okay.
But again, also I'm not a lawyer, so I may be misreading it all. Um, it doesn't look like there's any difference with PCI Express 4.0 power provision. It's still going to be
Oh, okay.
75 watts from the slot.
Okay.
Um, at least
Um,
according to Kit Guru.
so
So
VR6 Doug on YouTube, he has a question. He says, will you guys be doing some tests with the 30 series cards to see the kind of scene complexity that is possible with various VRAM sizes?
that would probably trend more toward Kelly's area.
Mhm.
I would think, I mean, unless he's meaning like specifically rendering stuff. And again, if it's the rendering side he's thinking of, not so much, because again, we're currently anyway mostly just using the pre-built benchmarks from V-Ray, Cinebench, Otoy for Octane Render, and
Mhm.
Redshift, which is
Okay.
Maxon. So oh yeah, I see. Yeah, so not specifically. That's again, I think that's something that could be really interesting to get into, but I'm not a 3D modeling guy to be able to like put together those scenes well. Like I could
Got it.
try and scalp ones online that are free and open source or something, but I think that would be something that would be awesome, maybe to work with Kelly on at some point when he's got
Okay.
some extra time someday in a few years,
Yeah,
once
right.
he's
Sure.
up to caught up with everything he wants to do now. So yeah, and it's also, I mean, there's so many things. There's the geometry, but there's also the texture size and complexity and the resolution that you're rendering. I think there's a lot of things that go into that beyond just, one aspect. So it'd be hard to, you'd have to test a lot of different things to sort of come up with a scheme for how to figure that out.
Okay.
Yeah.
Huh. Yeah. Let's see. Maybe I'm missing questions here. I don't think so. Let's see. I'm curious. What's something about the the things that you've looked into, photogrammetry, engineering, CAD, the rendering stuff? What's something that people don't realize that you think they should know?
Hmm.
Like,
Something people don't realize that they should know.
mm-hmm.
That is a fantastic question that I probably won't be able to answer very well on the spot.
Oh.
Uh, yeah, I can't think of anything specifically. I guess I would say like, um, at least if they're looking for a new system and interested like in a system from us, talk to us. We've got a ton of information on the website,
Mhm.
and you can in theory buy a system without ever having to actually talk to someone here.
Sure.
But our consultant
It's
guys,
not
I used to
recommended
be one
though.
of the consultants for 9 years. They're great guys, they're friendly, and they will help make sure that you don't make a mistake in what you're configuring, that you're
Sure.
getting the right thing for you. Oftentimes we were able to save people money and get them,
Mm-hmm.
the same level of performance, or sometimes even better, more optimized performance for what they're doing for less money than they realized with their initial design. So
Mm-hmm.
definitely talk with our guys. And they can also help, they're not experts in everything, but they can get in touch with us labs guys, and they can also look up stuff online to try and help, even if it's something that maybe we don't specifically have a configuration for. We can try and do our best to help out, again, just to make sure people aren't making mistakes. And Yeah, that's probably the biggest thing. But again, it's not really a workflow specific thing. It's more a Puget Systems thing. So
Sure.
plug.
Sure. Well, okay then. I'm curious then, has there been any something, I suppose, a challenge that you've encountered in kind of like developing the testing or having gone through this testing that you've solved, like that stands out as particularly challenging?
Well, one thing I know, so on the engineering side, with our SolidWorks testing, which originally Matt had developed years ago before I started in labs, but I've kind of taken over. We had been using some small, well, relatively small to medium size CAD models that I think were ones that maybe came with some test stuff from SolidWorks or somewhere like that. We'd sourced them online somewhere that they were freely available and other people were using them. But when it came to video card testing, I don't remember exactly which release, but we sort of hit a point where the video cards were all fast enough to handle those models, even like
Hmm.
down to the fairly low end quadros at the time. Um, and so we needed something bigger. And again, I'm not an actual engineer, so asking me to put together a complex thing would have been, it either would have come out stupidly complex but very unrealistic, or not nearly complex enough. So
Okay.
we actually got together with a gentleman that we'd worked with on some other stuff, and he was able to provide a model. It's actually kind of cool. It's a model of a very complex Lego set done in
Oh,
SolidWorks.
neat.
And it like 40 million plus polygons, something like that, or triangles. So very, very complex. And that then we were able to use, basically just slot it in place of one of the other models and actually see some differences between cards. And then since then, SolidWorks has also upgraded the way they're using the video card, so we actually can see even a wider range now. Even on some of the smaller models, they're using the
Oh,
video card in a more advanced way when displaying those. So we've seen performance increases again from that too. But just that was one of those interesting ones. Like with the data we had, it looked like anything from the lowest end quadro to the highest were all almost identical until you actually used a bigger, more complex model, and now you could suddenly see a difference. So there's definitely times where things like that come up in our testing that we just need to increase the complexity sufficiently to start seeing differences.
I see. And so we haven't quite reached that same point again, have we?
Not in SolidWorks, at least. No.
Okay.
That is one of the things, like we with our photogrammetry testing, for example, we have
Mm-hmm.
two separate benchmarks. We have a really quick one that only takes 10 or 20 minutes on each of the applications. And that's the one we run like on every system in production just to
Mm-hmm.
make sure it behaves. But then, it's hard to see sometimes performance differences there with stuff that's only taking a few, anywhere from a few dozen seconds to a few minutes to run a specific part of the software. So we
Mm-hmm.
also have much larger image sets that we run up in labs, and occasionally in production, like if a person is specifically doing photogrammetry with their workstation, we'll run one of the longer tests. And you can much better see the differences between hardware with those more complex tests, partly just because they take longer to run, but also partly because they're using the hardware more intensively.
Okay.
So that definitely comes up sometimes.
I see. That's pretty cool. Let's see. Timo TT on YouTube here is asking, are the 590 and 690 style double GPU cards for the present or the future? I'm not sure
I'm
what the question is there.
I'm not sure either. 590 and 690 are not anything current in terms of Nvidia model numbers. Is that some new AMD stuff? I don't keep up as well on their video cards. But I don't think that's only 3 digits. Most of the cards these days people tend to use
Oh, it
four
might be
digit model
referencing,
numbers.
and I think he's referencing an older model
Like,
of GPU, because Don pops in and asks and says dual GPU cards are probably history because of the power requirements. So I get the feeling back in the
he means
day.
the two GPUs on a single card.
Yeah,
Okay. I was thinking dual cards for dual GPUs. No. Yeah, I very much doubt
I can't
that we'll
I
see
can't imagine.
dual GPUs on a single physical card
Yeah.
ever again. Like, we're kind of to the point where it isn't necessary. The reason they did that in some of those generations were the single GPUs weren't hogging enough power. So, hey, why don't we put two of them on a card and get more performance from a single card?
Hmm.
Nowadays, I mean, the 59 or the RTX 3090 is rated for, I think, 350 watts, but again, in testing I've seen other places do, seems to sometimes pull 400 or even higher watts under turbo.
Whoa.
There's no way you're putting two things like that on a single card, and you don't need to. Like,
Right.
technically, they're already pushing past the PCI Express standard is supposed to be a maximum of 300 watts per card. And it was kind of funny because a few years ago, AMD passed that with one of their cards. And I remember everybody
Hmm.
going, ha ha, AMD power usage shouldn't be
Yeah.
doing that. Now NVIDIA's
And
doing it.
I think that's because they hadn't like said it like publicly. Like Nvidia said, "Hey, we're pulling this power." So I think that was the
Maybe. I don't recall all the details. I just remember everybody getting a tizzy over AMD doing it, and now NVIDIA's doing it too. And, I mean, in realistically, the only reason, like, you could have as much power draw on a card as the power supply is capable of providing and the cooler is capable of dissipating in a reasonable
sure.
manner. So, I mean, theoretically, that could go higher. I think they had tried to set that 300-watt spec probably at what seemed like a reasonable amount, factoring in power connections and all those sorts of things. But clearly, we're beyond that now. But I can't imagine, putting like two of those on a single card. It would have all sorts of complex issues. And again, the reason to do that would be like if you needed more power or performance density and weren't at that power limit yet. That's a way
Right.
to get closer to the power limit by having two GPUs on a single card instead. Um, so And there's weird form factor stuff too. Like if you get into outside of just traditional power tower PCs, laptops use a much smaller little weird MXM card when they have
Hmm.
dedicated GPUs. And then
Right.
you get into some server stuff, and there's all sorts of different weird form factors for having GPUs in a more condensed form. Still a
Sure.
full blown GPU and memory and everything, but in a smaller, more compact package if you have custom cooling and stuff available. So there's all sorts of weird things that can be done
Yeah.
to cram more performance in, but dual GPU cards probably not going to happen again.
Yeah. So we have another question from YouTube. Dipanshu is asking for a little clarity on what is photogrammetry.
Oh, yeah, I suppose for those who aren't familiar with it, it sounds like kind of a weird term. I think it gets mistaken for photography sometimes, but it's
Yeah,
it's the
because he
practice
did
of
mention
taking
Photoshop.
yeah, it's the practice of taking a bunch of different still images and of an object or a location from different angles, and then using a computer to process those into a 3D model of that item or location. So, if you can imagine, like, just simplistically, if you just have a handful of photos around, say, an object on a desk, that's enough. If you can see all the different angles around it, then in theory you have enough data to put together what that model actually would look like in 3 dimensions. And so that's what they're doing. And again, it can be used for all sorts of different stuff. One of the cooler things I've seen people using it for lately is taking pictures of like architecture stuff, old stuff, so like ruins of
Oh.
things or old
Mm-hmm.
churches or stuff that's heritage sorts of sites, so that more people can see them. Otherwise you have to physically travel there or just settle for a few pictures or a video or something. But being able to actually like do a walkthrough of some ancient building or castle or whatever is some really cool stuff. So a lot of times you'll see it paired with drone usage, of course, because you can automate the taking of a lot more pictures in a lot shorter time with a drone than if you were physically walking around with a camera. And then for really nice, fancy setups of object photography, people will do these whole huge arrays of 50 or 100 cameras around an object, and they can take the picture all at once in the same condition and just instantly have the photos necessary and then throw them into a computer for processing. Um, and I see someone saying, why not just use VR?
Uh-huh.
This is something you can use to then set up a VR experience. Because in order to have a 3D model of something, traditionally you have to create that by hand. You have to go in and create all the polygons and the structure and bring in textures and all that. This is a way of shortcutting that, so that instead of making it all manually, like instead of taking reference photos of a castle, going into 3ds Max or Maya, modeling the castle, getting photos of the texture, importing the texture, putting it in the right places, you could instead just fly a drone around the castle for a few hours, take all the images, go through and remove ones that didn't turn out good or whatever, and then throw it into a photogrammetry application, let it sit there processing for a few hours or a couple days. And in the end, you still usually have to do some cleanup, but you have the start of a 3D model of everything. And then you can
Mm-hmm.
go in and clean up spaces where the calculations didn't quite go right or whatnot. So there's a lot of times touch up that you'll want to do afterward, but it's way, way easier in terms of manpower than doing it all from scratch.
Yeah.
And a lot of times they'll use that for like making props in video games nowadays, especially of
Mm-hmm.
stuff that's not simple to model. Like you want realistic looking rocks, right? You could spend hours making just one realistic looking rock, or you can take 30 pictures of it and throw it into a photogrammetry program, and now you've got a rock. And you do that a bunch of times to get a bunch of different rocks and then put them in your game. um, so yeah, there's tons of different use cases for it. I think it's something that's underutilized at the moment and that will just get
Oh
more
yeah.
and more popular over time,
I know.
especially with how cheap and easy drones are getting to operate and stuff like that.
I think actually we have a case study with a company who did the heritage style things. They um it was like a graffiti park, and that
Ooh.
was getting torn down, and they went in ahead of it, took a bunch of pictures. And I mean, it's horrendously like simplifying the process, but they take a bunch of pictures and actually did create a virtual reality experience for it, so people could still um, like visit this place that's now something else. Like I don't recall what they did with the space afterward, but it had been a place that was like um, very relevant to the community and things like that, and they wanted to be able to preserve that space,
Yeah,
um, and it's pretty cool.
perfect example. Yeah, stuff that won't exist anymore. You can get it digitized, and then at least it's around for people to experience in some form, VR or even just on a computer or phone or whatever. Yeah.
Oh, and then it looks like you went and answered the scaling of number of CPU cores. So just for our audio audience, Random Slurping has asked, does photogrammetry performance scale linearly with the number of CPU cores you have in the system?
No. And it depends a lot on the individual program. And the photogrammetry programs, there's bunches of them out there. We test 3 of the bigger ones, but I know of many, many others that we don't test. And I don't know how all those behave, but the ones that we do test, there's some variance. Some tend to scale a little bit better with CPU cores, others don't. But there's a lot of steps in photogrammetry. And what you'll find if you break it down into those individual steps is some steps tend to be more parallelized, which allows them to work across multiple cores better. And then in other steps, sometimes the calculations of the next thing you need to do depend on the current calculation you're doing. And if you're in a situation
Okay.
like that where you can't figure out the answer to the next problem until you finish the one you're on, that really is what they call single threaded. It can only do one thing at a time, or serial. And so there's steps that are like that. There's steps that are more parallel. In some of these programs, there's steps that use the video card and then steps that don't. So there's a lot of things that factor into it, but it is not just a pure throw more CPUs at it, it's going to be better thing. It's a balancing act between number of cores, clock speed, video card. One thing that does scale in terms of necessity for larger projects is RAM, because you're talking about a lot of data and a lot of images that you have to keep in memory. So it's not that more RAM increases performance, but that to deal with larger image sets, you need more RAM. And there's some of these programs can also cut up big data sets into smaller chunks and deal with them. If you have 10,000 images, maybe it breaks them up into chunks of 2,000 and processes each of them separately and then stitches it back together in order to deal with things like ridiculous memory requirements. So there's a lot of that stuff.
Yeah.
And yeah, certainly caps at certain CPU core counts in terms of our testing anyway. Like,
sure.
I know a Metashape, for example, one of the more popular ones. It certainly seems like anything past around 16 cores actually starts to slow things down. And I don't know if that's purely because there's some weirdness that it tries to split things out, but can't do it as efficiently, or if it's just that as you go higher in core count, you start to lose clock speed. And that's what's doing it. But something, certainly, you're really not getting performance gains past a certain number of cores. But then even that, there's ways around, because some of these you can run multiple instances of. So if you have more cores and a couple video cards, you can split the cores up, put a video card on each one, and then just run 2 instances at the same time if your workflow needs that or could benefit from it. So there's a lot of different factors. Again, which is why we put out the articles and the testing stuff, and why we recommend that you get in touch with our guys if you want to buy a system, so that you make sure you're getting the right thing.
You had mentioned that certain steps kind of require different, either CPU, single threaded, multi-threaded, GPU. Are those steps, can they be split out? Like, could I have one machine that has like the best CPU possible to do those steps that would benefit from it, and then have another machine to do the rest? Or is it something that has to happen all together?
In theory, you could. It depends a little bit on the software as to how granularly you can break things down. For example, Pix4D, if you're processing a model, it literally just breaks into 2 steps. If you're doing a map, there's a 3rd step. But if you're doing a Metashape and reality capture, they break them down into more like 6 or 7 steps. So yes, in theory, you could process the first step on one computer, copy all the results over to another computer, then process. But I think you would
This
probably
seems
lose a lot more time in the
okay.
effort done to do all that than you would gain from performance.
I see.
Because it's not like they're hard to build systems for. Again, depending on the application you're looking at, a lot of them max out at like a 16 or a 32 core processor. Usually one video card. Metashape in the past seems like it could use multiple video cards, but it's like each generation of video card has gotten better performance, and then the benefit of having multiple cards has reduced in
Right.
Metashape. So we're at the point where it's not like you need a ridiculously powerful computer to get the best performance out of these things. The main thing comes usually down to like memory is the
Okay.
thing that kind of has to ramp, and that can be limited. Lower core count processors tend to support less memory at maximum as well. So you
Okay.
can end up in situations where you're like, well, the best CPU for this would be a 10 core, but I need 512 gigs of RAM. So I have to go with a more powerful system that's maybe not as effective in certain steps. But yeah, there's a lot of different stuff that goes into that.
So I'm gonna take this last question, even though it may not quite. But I just think this is a fun one.
Yeah.
Why are all of the consoles using AMD GPUs when we know Nvidia is the best for gaming?
Well, so consoles, keep in mind, consoles are not using the absolute fastest hardware out there. That's why they only cost $400 or $500 when a single 3080 is $700. So they're going for some, I mean, I don't know what exact financial decisions drive Sony and Microsoft and whatnot, but they're going for some sort of combination of the best price performance they can get at certain specific price levels. And I know my impression is anyway, I don't deal a lot with AMD video cards, in part because they just don't have as high end of cards as Nvidia does right now. And in part because historically we've seen less driver reliability with them in Windows, at least. So, but my impression is on the lower end, lower to mid range, that they're reasonably decent in terms of performance. I know AMD as a company is, I mean, fantastic. Look at what they're doing with like the Ryzen processors and stuff. They've been killing it the last couple generations. So I'm sure they're a good company to work with in terms of that sort of stuff. And if you're in a situation where you have a fixed hardware platform that you're going to sell the exact same thing for years, well, then they can probably handle dialing in drivers and reliability and things like that way ahead of time. So I think, I'm sure NVIDIA tries to compete and gets that. And I think, if I remember right, in past generations, it's gone back and forth between who's making the CPU, who's making the video card. I think there's intentionally competition there. We want that, right? Like as consumers, we don't want one company to be doing everything. We want Sony and Microsoft and Nintendo, and we want Intel and AMD and Nvidia and AMD, so that there's competition driving performance and prices and all that.
And soon to be Nvidia, AMD, and Intel, as well as Intel and AMD.
Yeah, I don't know. I don't think they're going to make x86 processors, but on the ARM side, that's
Oh, I was thinking more Intel GPU.
Oh, right. Yes, Intel's supposed to be doing that too. Yeah, that's true. I don't know where that's going to end up going. We'll see. Again,
we'll get more Phi
cards. Good, Yeah.
We'll end up with a new generation of Phi card, right?
Hopefully, it's not that. But
yeah. Let's hope. We fingers crossed. Well, awesome. Okay, that does bring us a little bit over our hour for our Labs Open Office hour. I want to thank. I suppose one last question. What do you think about VMware on ARM?
That's probably outside my area of expertise far enough that I shouldn't comment a whole lot. I know personally, and all the software that we're running on Windows these days is designed to run on x86 or x64 stuff. And it's a very different architecture from ARM. I know you can do emulation stuff these days, and I think that's probably some of what like VMware is trying to get into there. And I mean, maybe, but like, I don't know. We'll see. I don't know what ARM can do in terms of the high end performance, right? Like the fantastic for low power usage, stuff like phones and everything, tablets, and server workloads, where a lot of times in servers you care a lot less about just raw performance and more about power efficiency or, again, parallelization, instead
Right.
of being the very fastest with one application, doing a lot of things very efficiently at the same time. So
Hmm.
there's definitely an area there. I know Dawn's been really interested in ARM, and also there was some other standard for a while that was bouncing around that I don't think seems to have gone anywhere. But open, some sort of thing, some alternate CPU architecture, yeah, that someone was trying to push. And I remember several years ago, Dawn being all about that. And it's interesting stuff. I don't know what it would take to replace x86 and x64 architectures on PCs.
Right.
Maybe we'll see it someday, but open power. There we go. Don just dropped that in the comments. Yeah, you can tell us next time you're on here, Don. Did open power go anywhere? Because I remember it being the big thing 3 or 4 years ago that we were all, are we going to be on open power instead of Intel in a few years? No, it hasn't happened.
All right.
And Intel and AMD are putting out amazing processors, so I don't really see a need for it either. I don't know. But if ARM can ramp up to the same level of performance, then maybe that'll do something. Again, competition's always good.
Yeah.
I my big personal worry is always backward compatibility. I don't want them
Sure.
to like shift to ARM and be like, great, we're on ARM now, but everything made before 2022 no longer runs. Like something like that, where just old software just doesn't work anymore. No,
Compatibility mode.
that's that's the thing I love about Windows, is that they've maintained backward compatibility. I can still run software from like the 90s if I want to,
Yeah.
old games and stuff like that. That's one of my favorite things. So um, maintain that compatibility, ARM. If you do try to pull some weird nonsense, make sure it still is compatible.
Oh, all right. Okay, so we'll call it there. Thank you very much, William, for taking time out
Yeah,
of the
my
day.
pleasure.
This it's always good to. It's always interesting for me because I get to find out what everybody else is doing a little bit more, and I want to thank you as well, the audience, for joining us today
Yeah,
for our lab's open office
good
hour. We do
questions.
this, yeah, yeah, good stuff coming out of the audience today. We do this every Wednesday and Friday at 1 o'clock Pacific Standard Time. Wednesdays are industry experts from outside the company to kind of give a peek into their workflow and process, and then Fridays are our internal experts like William here, and to give a little more insight into the crossover between the software and the hardware and what that means for you as a customer or as a professional. So mark your calendars: Wednesdays, Fridays, 1 p.m. Pacific time, and we'll see you guys next time. Bye.
Cool. Bye.